All right. As things settle down a little bit, we'll get started here, and maybe we'll start with some introductions also. So welcome, everyone. I hope you are having a good Red Hat Summit. This is the first one that is at full force after COVID, so we survived that. We're here to talk to you about OpenShift, give you a very brief overview. I'm assuming most of you are familiar with it if you are in a roadmap session. But what we are going to mostly focus on is what are we thinking, what kind of innovations are we thinking on behalf of our customers and bringing them to them, right? In the way of introduction, I'll introduce myself and we'll get going. I'm Tushar Katarki. I am a product manager. I've been on the OpenShift product management team for 6+ years, 7 years, and I have dabbled with all parts of it, if you will, over the years. So I know a little bit about everything in that land, and very excited to be here. I've been at Red Hat for 10+ years, and thanks for joining us today morning. Judy, you want to introduce yourself?
Sure. Thanks, everyone, for coming today. My name's Ju Lim. I've been with Red Hat nearly 8 years, and I'm also, like Tushar, part of the product management team. I work on the core platform, and I tend to focus on installs, updates, and all those wonderful provider and different flavors that you work with.
Thank you, Ju. All right, so without further ado, I think we can get going. I think in the way of level set, right? What we say is that our customers are faced with a very hybrid environment, and when we say hybrid, it's easy to understand hybrid through the lens of infrastructure for sure, right? There is public clouds, data centers, edge, etc. But I think applications are also hybrid, right? So you can think about you all having a diverse portfolio of applications and services. And you can see some of that flavor here. And then your tools, your processes, and the different kinds of people who touch them, right? Different personas. It's all hybrid. So we've been talking about hybrid for 10+ years at Red Hat for sure. This is that's the environment that we think our customers, we hear from them. This is the environment that they are faced with. So what OpenShift has been doing is that for our customers, we are delivering, we have built a platform to deliver consistent applications, be it cloud native, be it AI or machine learning type applications, or even traditional applications that are secure. There's automation, and we have done that through two things: communities of innovation, open source, and an ecosystem of partners and the solutions that they bring. So we continue to do that. Red Hat OpenShift is very pivotal to that, so to speak. OpenShift is available as a fully managed cloud service on AWS, on Azure, on IBM Cloud, and on Google Cloud, right? Or you can run it yourself as a self-managed platform, and that you can do it any of these clouds or more clouds than this actually, and other kinds of infrastructure. That's something that Ju is very involved with, that she was talking about. In Q4 of 2022, it was a bit of a proud moment for us when, as a business, OpenShift itself achieved $1 billion in ARR, and it's taken us 7+ years. We continue to be the top 2 contributors to Kubernetes, and we are involved with 50 other CNCF projects, some of which you will see in the following slides. And we have done that. Through success of 3,000+ customers, and this is really a proud moment to kind of celebrate that. Now, talking about what we are going to do the rest of 2023 and beyond, I thought I'd highlight 3 key themes, and we're going to walk you through these themes. But the first one is, how do we go beyond Kubernetes? And I'll explain that in the following slides. How do you go beyond cloud-native applications? And how do you go beyond the cloud, right? So that's the theme, and that's what we think we've heard from our customers, and we're building OpenShift roadmap based on these themes. So what do we mean by beyond Kubernetes? It's all about developing and deploying cloud-native apps consistently and securely, as I talked about before. I mean, Kubernetes was born for cloud-native applications, right? We all know that. So, there is that. But Kubernetes is not enough, right? You all know this. You've heard this at the keynotes today. If you are at the OpenShift Commons, some of you may even have presented your case studies and have you used OpenShift. But what our customers want really is, if you think about innovation and code that developers write, you want to get that to production and to your users as quickly as possible, and that's the typical software life cycle, right, that it goes through. What we have done is that we have invested in open kube native tooling for each one of these things. So if you think about starting with OpenShift build, OpenShift pipelines, and OpenShift GitOps, that allows you to build code, to test it, to continuously integrate it with other pieces of code and artifacts, and then we have brought that deployment of that with OpenShift GitOps through Shipwright, Tekton, and Argo CD, as well as with the ecosystem of partners. So we'll continue to invest in what we call the kube native tooling built on Kubernetes with the CNCF ecosystem to bring, that's going to be a major theme. So one of the specific ones that I wanted to point out really is, supply chain security. I mean, in the past 2 to 3 years, I would say, with the Log4j, if you recall, and what happened with SolarWinds. Security is in everybody's mind, and it's not just about this is at runtime security, which we have been talking about for many years, right? But this is about how do you secure the entire supply chain from cradle to grave of the code, right, so to speak. So we are excited to announce 3 kind of products and extensions to an existing product, and you saw some of that at the keynote today, and some of it was mentioned yesterday too. The first one is Red Hat Trusted Content, and that allows you to do software composition analysis at coding, software composition analysis and dependency analysis. And then with Red Hat Trusted Application Pipeline, what you can do is that you can build that code and you can digitally sign it, right? So that there's a provenance of where that code came from, where that artifact came from. And then once it's deployed, even before it gets deployed, ACS helps you to make sure that it has the right signatures, it has the right sign, and make sure that there are no vulnerabilities, etc. Both even before letting that code onto the Kubernetes or OpenShift cluster, but then also continuously does that. And all of these, again, as I said, are kube native, and we'll continue to enhance these and bring more of this as we go along here. So that's one of the major focus areas. The other one that you saw is, I know it's been, is the Red Hat Developer Hub. Application developers, when you onboard them, you want them to become productive very quickly, all right? From months to weeks to days has been talked about, and in fact there was a, and then beyond that, you want to increase developer productivity, you want to reduce their cognitive load, so to speak, and you want to do that on open source tools and technologies. So with that in mind, Shipwright, Backstage, is a very popular tool in this space that has emerged, and Red Hat is contributing to Backstage. It's a CNCF project, and we're doing two things. One is we are bringing that to you in a product called Red Hat Developer Hub, as you can see here. And the other thing we're doing is we are adding to, in addition to contributing to Backstage, we're also adding 6 new plugins, as you can see here, everything from Keycloak to Argo CD to Tecton, and Multicluster with OCM. We are adding these plugins in what is known as a Janus community project, and then we are going to add that all over the coming year to Red Hat Developer Hub. So that's the plan there. This basically allows you to create those this allows you have now a platform for your developers to take advantage of golden paths and become productive very quickly. The other thing, Red Hat sustainability and what we are doing, and I think Chris Wright was talking about how we want to do our part in, sustainable IT, right? And to that end, one of the key things that you want to know is how much energy have you consumed, and you want to do it. How much energy has each namespace consumed, pods consumed, other resources consumed, and you want that kind of granularity. So what we have created is a project called Kepler, which builds in our observability tools that are already in place with Prometheus and primarily. And then the Kepler project itself is going to provide for monitoring aggregation of this power consumption information, and then that integrated with Open Data Hub, which some of you might be familiar with. I'll cover a little bit of it later. Open Data Hub, you can then analyze that information. You can potentially apply some regression analysis or even machine learning analysis to it, and you can produce reports as well as trends, and you can see. So that's effectively what we are doing with Kepler and Open Data Hub, and that's innovation that we are bringing to our customers through Red Hat OpenShift later this year. Beyond cloud native applications, what we mean here is that, again, as I said, how do we do more than just cloud native applications, and what does that mean? So we'll start with, applications can be everything from your traditional n-tier applications to cloud native microservices to AI and machine learning applications or ISV or packaged applications, right? So I'm going to talk specifically more about what application modernization and AI and machine learning in this section. So this is the familiar, machine learning kind of high-level workflow, if you will. Data scientists gather and prepare data. They train models. Developers integrate them into existing applications or new applications, and then they get deployed, and then they are monitored, right? So that's your typical. And then this is kind of a block diagram of what a machine learning platform looks like. You have your hybrid multi-cloud platform in the form of OpenShift, and you can create your machine learning pipelines on the left here, which access your databases and data lakes. And on the right here, you have all the tooling required to train models and then deploy them. So that's your, I think most people are familiar with this. So what we have done is we have built OpenShift Data Science, and the Open Data Hub that I mentioned earlier is the upstream to this OpenShift Data Science project. And the OpenShift Data Science project, it's not new, but what it does is it allows for data scientists to develop models, train models, serve them, monitor them, and manage the life cycle of the entire model, right? Like retraining and redeployment. And generally increase collaboration between data scientists, data engineers, and developers, as well as platform engineers. So that's basically what OpenShift Data Science is. Again, that's not new. What's new is, relatively new, is that it was only available as a service on AWS. Now we are bringing it in a self-managed, so you can install it on OpenShift and you can manage it yourself. So that's relatively new. And what we are doing now is, going forward, what we are adding to Open Data Hub, really, which, as I said, is the upstream to OpenShift Data Science. As you know, we always start upstream, before we start bring it into a product. So we are with our friends at IBM Research specifically, we are creating the CodeFlare project. Amongst other things, the key things of the CodeFlare product are Ray. Ray is a very popular PyTorch and Python-based tooling for data scientists. So we are taking Ray, and once they develop these models, they need to be trained, right? So to train, it's a computationally intensive process. And it's not only computationally intensive, but it also requires the underlying platform like Kubernetes or OpenShift to have certain tools which allows you to either schedule the whole thing together, which is known as gang scheduling, or not schedule until all the capacity is available, or if more capacity is needed, you want to create that capacity before it gets scheduled. So those are some of the problem spaces that we are tackling, where we are deficient right now within Kubernetes and OpenShift, and we are adding that through things like MCAD and InstaScale, and which both with MCAD giving you the job queuing capabilities, and InstaScale allowing you for that auto-scaling capabilities that I mentioned earlier. The other thing here to note is the CodeFlare SDK. The CodeFlare SDK allows a data scientist, through some simple primitives that they understand, to create this capacity and use that. And you'll see this is already integrated into Open Data Hub, and you'll see some of that getting into the OpenShift product itself in the coming months and quarters, if you will. The other exciting thing I want to quickly touch upon really is, and I'm trying to keep track of time, is really DPUs. NVIDIA coined this term maybe a few years ago. They call it data processing unit, but effectively what DPUs are PCI Express form factor devices which have ARM architecture on it, ARM chips on it, and then they could have other things like GPUs on it. The brand name is they're calling it BlueField, and we've been working with NVIDIA closely on how to integrate that into OpenShift. So the opportunities there are, offloading. I mean, everybody has heard of how, well, obviously, if you want to train things like ChatGPT or OpenAI models or LLM models or foundational models, etc., you need a lot of compute, and also you heard of kind of the Moore's law and the fact that the Moore's law is kind of leveling off, right? So people are looking to do more with existing capacity, and for that you need offload capabilities, and so that's what basically these DPUs are. You can offload capacity to it. The other thing that DPUs can do really is that it provides a separation of concerns, right? So you can say that and security and composability becomes important, because the DPUs can help with saying that, okay, look, I'm going to just run, I'm going to create a firewall and run the firewall on the DPU, and I'm going to protect access to the host, those kinds of things, or the enclaves, which is the other way to do it, which is, I want to do some extra computing, but you can do that on the DPU. So there's lots of things we can do with DPUs, and the next several years you'll see more and more innovation play out there. But this is the start of the journey for us, and you'll see we're starting off with one specific use case in mind, which is OVN and OVS offloading, and IPsec offloading is something that we are starting with OpenShift, as well as you can see OpenShift now running both on the host as well on the DPU. So that creates that separation of concerns. The next thing I want to quickly talk about, switching gears a little bit, is this is application modernization, right? So when you think about modernization, a lot of customers do it in steps, right? Like and so we have created with IBM a upstream community project called Konveyor, and downstream, and many of you probably are not aware of it, we have three products that you can, three toolkits that you can use. One helps with migration of applications from a non-containerized world to a containerized world, and then the other is about VM migration, and from a virtual machines, how can you bring it to things like OpenShift Virtualization? So that's basically the Konveyor project, and you see the three migration toolkit for applications, containers, and virtualization as products that you can use, and those are operators that you can use. use. What's next for Konveyor really is that so for those of you who are using it or intend to use it, we have a robust roadmap coming up for that. It includes better support for disconnected installations. Custom migration targets is something to be that we're intending to include quickly. And then a multi-language analyzer is coming in Q3, and then enhanced assessments can be done for different kinds of workloads or applications. We'll continue to add that, including the .NET support, as you can see in Q4 of 2023. The other thing that gets people, we're getting a lot of interest from customers is OpenShift Virtualization. OpenShift Virtualization, for those of you who don't know, helps you bring VMs to OpenShift. As you can see here, you have deployed OpenShift platform, you're running containers, and you can run VMs within containers. So that's what OpenShift Virtualization does, and it's a single platform that enables you to run both VMs and containers. And basically, you can think about it as a landing zone for legacy applications. The VMs, you can bring them as containers, and then you can, over time, think about how to further, modernize those applications so that it becomes a good starting point for that. So in terms of the roadmap, we're continuing to add more virtual enterprise capabilities to it, including things like CPU and network hot plugs, which are so important in the VM world, and memory overcommit, scaling to 10,000 VMs, multi-cluster support, and this one is kind of very exciting. Pipelines and GitOps integration for VMs. You can imagine, using pipelines to build VMs as well as deploying it with Argo CD. So those are some of the integrations that we are bringing starting soon. So with that, I'll hand over to Ju, who will talk about what beyond the cloud means.
Thank you, Tushar. So let's take a look at what's beyond the cloud. So to date, in the past decade or so, maybe a bit more, Red Hat has been helping innovate in on-prem with RHEL. And what we've noticed in recent years is a lot of customers, a lot of industries are starting to adopt public cloud. And what's happening there is we're taking note, and we're looking to explore what that is, and you'll see what we're talking about in a little bit. And then in the same light, we're also seeing a trend, on the edge side. So really what I'm trying to get at is we're continuing to innovate not just on premises, but we're also investing heavily in the cloud. We're growing and expanding sort of our cloud services. So today we have things like OpenShift running on AWS, on Azure, on GCP, Ali Cloud, and so on. And then what we try to do is provide differentiated cloud services in partnership with the hyperscalers so that you can actually gain some new capabilities beyond just what you get with the what most people think of cloud. And then on the edge side, we're investing heavily there. And so you'll start to hear about some of the new use cases that we're enabling in car vehicle processing and all the exciting keynotes that you heard this morning. Beyond that, as we start to build up best-of-breed solutions, we're also partnering with our ISVs and partners to actually help build out these solutions to help you build your own solutions on top of OpenShift and our partner ecosystem. So what do we think about in terms of fleet management? So I know there's a lot to see right here. We're continuing to invest heavily across the open hybrid cloud. And what this means is whether it's multi-cluster management with our Red Hat Advanced Cluster Management tooling, or whether it's a container registry with our Red Hat Quay, or on the security side with Red Hat Advanced Cluster Security. We continue to make investments in all of these areas, as well as all the way down through the networking layer, the compute, the storage, and all the applications that go with it. So all of this is intended to help you build, deploy, manage, operate, and deliver secure applications at scale, reliably across your hybrid cloud, whether it's on-prem, in the cloud, or at the edge. One of the things that we're focused on is ensuring whether it's your first cluster, your second cluster, or your 100th cluster, we want to provide a consistent and unified experience. And what that means is, over time, you'll start to see innovations within the OpenShift portfolio that move us in the direction where, whether you're working on OpenShift on vSphere or on AWS or Azure or at the edge, those experiences should be similar. And it will make it far easier to actually innovate and deliver your solutions quickly. So let's talk about hosted control planes. This is something that we announced this week. It's something that we're offering today, or we've just announced. Hosted control planes, for those of you who are not familiar, is a new form factor for OpenShift. And what this allows us to do, as well as you, is to be able to centralize how you actually manage your control planes. And what this means is we're starting to separate your platform management from your workload management. And through actually hosting all your control planes on what we call, if you look on the far left, the management cluster, we're able to gain efficiencies of scale. And so what that means is, instead of having to spin up VMs or bare metal in order to host the control planes, we're all going to centrally host it on the management cluster, hence the name hosted control planes. Your workloads continue to be supported or running on your workers, but now what happens is you've got greater resource efficiency, a clear separation of concerns in terms of security, and then at the same time, faster provisioning times, because you're not having to provision all that underlying infrastructure in order to spin up those control planes. One of the key things about this is that we're announcing that on Red Hat OpenShift on AWS, otherwise known as ROSA, we're making available a preview of hosted control planes, so you can try it today. Beyond just ROSA, which is a managed offering today, you can try it today as tech preview on AWS, on bare metal, as well as OpenShift Virtualization, or KubeVirt. And then over time, you'll start to see that we're going to expand this into all the other providers that I may not yet have mentioned. But the idea is this is going to become the more standardized way to do it, because we want to ensure that you gain those efficiencies of scale as well. So let's take a look at what it means to consolidate OpenShift clusters with hosted control planes. So in this particular example that you see right here, what we have is at the very bottom, the physical hardware or bare metal. We've got the hosted control planes all running on bare metal right here. And so in this particular example, instead of running the worker nodes on top of bare metal, we're actually running it on top of KubeVirt, or rather OpenShift Virtualization. And so as Tushar had talked about earlier about OpenShift Virtualization, it's a great way if you're looking to land softly, if you will, to bridge between your virtualized world as well as the containerized world. But taking this forward a little bit more, we're now applying hosted control planes together so that you can run them both on top of the same underlying platform or bare metal. So this gives you, again, all the great cost efficiencies, faster provisioning, more isolation, more security, and ultimately, it's also more centralized in terms of how you go about managing it. I think one of the key concepts that I probably should mention is there's a very clear separation of duties And so what actually happens is you have different personas or different user roles being addressed in this particular way. So let me move to the next slide. Oops. OK. Clusters as a service. So I don't know if anyone has heard about the cluster as a service operator. This is something fairly new. I think the big takeaway I'll tell you from here is this is about building golden paths. Tushar mentioned that with the Developer Hub. This is currently a community-based project, but the idea behind this is we're enabling service owners to build templatized or opinionated templates, which allow you to specify what that stack looks like, what the configurations you're going to expose, what knobs you're going to let your non-privileged users use in order to instantiate that template to go spin up whatever stack they're trying to spin up. And so what your template can contain is what kind of hardware, what kind of management cluster, what kind of infrastructure, basically, that you want on it, what knobs, what quotas. You might expose certain parameters to them, what are your cluster configs, and so on, what additional add-ons or plugins and so on you'd like to put there. But the key thing about this is now you have the ability to provide sort of bespoke templates for your different lines of businesses. So your different application developers or your DevOps engineer, they no longer need to ask the infrastructure folks to do the provisioning for them. You can start to enable self-service, but this is totally with guardrails. But the most important key message here is it enables your non-privileged users or developers to be able to innovate faster with something that's very clearly defined as to what paths that they should be taking. So multi-cluster end-to-end networking. So as mentioned earlier, we're focused very much on providing a unified and consistent experience across OpenShift. From a networking perspective, we know that today there are a lot of ways to, or a lot of different experiences on how you manage ingress, egress, OpenShift virtualization, OpenShift service mesh, and so on. So with where we're headed in the future in terms of networking, we're looking to make that all consistent. So starting at the very top, you see Gateway API. This is the next evolution of ingress and routes. And basically, that's going to start to unify there. And then as you start looking further out, what we're trying to do is ensure that how you set up and how you manage your network is the same, whether it's at the gateway API level or with the layered products like OpenShift Virtualization or OpenShift Service Mesh. We want to ensure that you manage your ingress and egress the same way. We also want to ensure that that interconnectivity works within the cluster, across a hybrid cloud, whether it's on the core, whether it's at the edge, or whether it's in the cloud. One of the exciting areas that to talk about is Submariner. This is a layer 3 interconnect, and this is today part of Red Hat Advanced Cluster Management, RACM as we sometimes call it. And what this does is it provides pod-to-pod, pod-to-service, and service-to-service interconnectivity. And one of the things about it is beyond just focusing on interconnectivity, it's also providing service discovery across clusters and providing things like load balancing, service failovers. And further down, we have Scupper. And in yesterday's keynote, if you saw it, we talked about Red Hat Service Interconnect. Sorry, we have too many Red Hats in our product name. I struggle. We changed that product name too many times. One of the exciting things about Red Hat Service Interconnect, or SCUPR, is that it's focused on the applications. And just as I talked about clusters as a service just now with those templates, this one is enabling you to be able to set up connectivity between your applications, again, without having to depend on your infrastructure folks. This enables your developers or DevOps engineers or non-privileged users to set up their interconnectivity or being able to link between your clusters and infrastructures outside of the clusters. So you can even connect, let's say you've got a front end that was developed and containerized in OpenShift. And let's say, for example, it needs to access some back-end resources that's in a virtualized infrastructure. You can use SCUPR to do things like that. So think of these as showing sort of the direction of where we're headed, and this will start to come together more seamlessly in the future. Multi-architecture across the open hybrid cloud. So one of the areas that we're investing in is also in multi-architecture. And today, we already support x86, ARM, IBM Power, and Z across the hybrid cloud. And this is also on AWS, on Azure, as well as on bare metal. So in this particular example that you see right here, let's say you start off by creating your cluster, and most people tend to start with an x86-based cluster. And then let's say you've been running for some time, and you might have a workload that will do far better with something that's ARM-based, or you want to take advantage of some of the cost benefits or performance that you get with ARM. So on day 2 or post-installation, you can go add some additional compute that's ARM-based. And then after that, obviously schedule those workloads to your ARM-based compute. So if you want to hear more about this, there is a session, there are actually 2 sessions about sort of mixed architectures. One that's just specific around mixed architectures, but we actually have a customer, Amadeus, who's a technology provider for the travel industry, and they're going to be talking about how they deployed their mission-critical application on a mixed architecture of both x86 and ARM. So definitely go check that out. So I don't know if anyone here has heard of Insights or uses Insights. Can I take a quick poll? How many folks here know about Insights or use it today? Oh, that's awesome. Good to hear. So today, Insights, we have this for Red Hat, for RHEL, for Ansible, as well as OpenShift. So on the Insights piece, if for folks who are not familiar, this is a recommendation tool. It is provided as a free service. It comes complimentary with your Red Hat OpenShift subscription, at least the OpenShift portion of it. And what this does is it takes a look at your existing clusters when you have it installed, obviously. And basically, it will provide recommendations based on best practices, our experience running a fleet of our own clusters as well as customers' clusters from our managed service, our customer experience, and all that remote health telemetry information or health statistics that we get from all our customers that are willing to share that information. And what we've done is we've actually built and trained a machine learning model to actually identify patterns, to come back with recommendations on how you can actually have a more optimized clusters. We'll analyze for potential issues. And what we're excited to tell you about is we're about to introduce Insights Advisor. And what this does is it analyzes the risk within your clusters to see, are there any potential risk if you were going to update it today? And what you see right here is it's in beta, but This is something you can go out and try. Just go to the catalog and get the operator to give it a try. Today, this is going to be available with not just on the update side, but also on OpenShift Data Foundation, or ODF, as well as the cluster autoscaler. And then what ends up happening is you'll see this through the hybrid cloud console within the cluster history. So if you see, I know it's hard to see. Sorry, I shouldn't say if you can see, because if I'm sitting at the back of the room, I probably can't see anything. What we're actually showing you are the update risks on the right, and then we will also provide you recommendations on how you go about remediating them. All right. We talked a little bit about Edge. So as mentioned, Edge is very important to Red Hat. We recognize that customers or organizations such as yourself actually want to run workloads closer to the edge, possibly to do processing, data collection, or running applications to serve out your users, or applications closer to where they're needed. So I'm happy to say, if you've looked at where we started at the core enterprise, we have expanded all the way to the far edge. And so today, most everyone, I'm sure, are familiar with our standard HA clusters. What we've done is, as we've moved further out to the edge, we've taken that density of footprint and made it smaller. So at the edge, you start to see footprints such as 3-node compact clusters. So it's a smaller footprint, but it's still HA. And then as you push a little bit further out to the edge, we start having things like single-node OpenShift, smaller footprint, remote worker nodes, and then at the far edge, we have something called Red Hat Device Edge. And this is for highly constrained environments. So when you're maybe in a bandwidth-constrained environment, potentially have sort of a rugged or very small, think Raspberry Pi type footprint, and you're wanting to run your application on a drone or robot or some kind of very small device, that's what Red Hat Device Edge is all about. So Red Hat Device Edge, if you're not familiar, this is something that we introduced late last year, or announced it. Today it's in tech preview, and basically what this is, it's based on RHEL for Edge. You're able to run containers, you're able to put RPMs on it, build your own solutions that way. You can also run VMs with KVM, but it is basically a RHEL with minimal profile with Podman running on it, but check it out. Anyone here running any kind of edge-based applications? All right, super. And then Hybrid Cloud Patterns Project. How many folks have heard about this? No. OK, I get to tell somebody something new about it. So this is a pretty exciting project that we have. If you go to hybrid-clouds-patterns.io, what we have here is a pattern library. And so the way to think about this is a blueprint or reference architectures. These are delivered as code. So these are working solutions in partnership with partners, as well as some of our ISVs and OEM partners. What we've done is we've actually built solutions together with them. And so this is a collection of solutions to actually solve real-world problems. So for example, there's one on medical diagnosis, and I think this was done with the Department of Veteran Affairs. We actually worked together to actually build in automated pipeline to actually do chest X-ray diagnosis using sort of GitHub space pipelines, as well as using OpenShift and some of our other solutions in our portfolio. But that's one example. The Industrial Edge one is quite interesting as well. That one's also leveraging serverless and an AI ML model to actually help boost manufacturing efficiencies. But I think one of the more interesting ones is around multi-cloud GitOps and multi-cloud DevSecOps. And what this is, an automated CI/CD pipeline to actually help you build and deliver secure applications at scale. And so I've had a lot of customers and partners tell me how awesome that one is, especially for getting started. And so you can go to a particular website. The slides will be available. And you'll be able to just git clone or fork it and start. And these are patterns that are continuously tested and validated. It is completely open. It's pluggable, so you can plug in your own components if needed. But we invite you to collaborate on it. And then let's talk a little bit about the roadmap. I know we showed you some of the direction of where we're headed. We, to date, produce about 3 different releases a year. So roughly about every 4 months, you'll see new releases, whether it's across the platform, across the developer space, or the applications, or hosted, which is our cloud services. We're continuing to innovate and work towards customer-requested features all the time. So if there's something in particular that you didn't see here, it might not have made the small print, but let us know. We're happy to have a chat about it. Lastly, thank you so much for joining us. Do check out some of these exciting sessions. If you have questions, feel free to come out and chat with us or stop by the Ask the Experts booth, and happy to take your questions. Thank you.